So this is the recording that I'm doing for the class period on Halloween of 2022. So today I just wanted to go over how to create, update, and delete data in databases. Because up until now we've just been selecting and rearranging, joining together tables that already exist in a pre-structured database, but you haven't created anything on your own. And I wanted to go over just some of the basics of that in today's class. So first off, to get started here, and also I'm uploading this SQL file to Learning Suite and on Slack. So rather than typing everything out, just open that up and try and experiment and follow along with your own computer if you can. But before we start, make sure that you select over here your own personal database. Before, we've been working primarily in Redcat here with the different tables like customer and employee, etc. So just double click on your own database so it's bolded here, or just run use and then type out the username that MyEducator granted you there, and then you'll have access to a blank database, which allows you to create and delete any data. In Redcat, of course, I don't allow you to create new databases or delete anything because that would just mess up the whole class. So after you create your, or after you select your personal database, you can create a table using a create statement, which is structured like this, where you say create table, you give it a table name, and then you specify what those column names are, and then you have to specify a data type. And we've mentioned data types briefly, but let me just go over 4 of those that we're going to be using commonly, that you've already basically seen in class, you just haven't created them on your own before. So data types define what type of data a column can hold. You can sort of think of it as a bucket that only accepts certain types of data. Like a column that holds the first name of someone should hold only text data, which could include numbers, but you read it as text. Whereas a column like quantity should hold numeric data like 1, 2, 3, etc. Or price also holds numerical data, but you want it to also hold a decimal point, so you have more precision in it. And then you have something like purchase date that we've seen, and that can hold a date, potentially a time as well. If you want more information on all the data types, you can follow this link. There's tons in MySQL, but we're just going to focus on these 4. So this first one is called varchar. And I'll show examples of this right below this if me just explaining is a little confusing. But this first one is varchar, which holds text data, which we often refer to as strings. So when you create a table, you say a column name, like you could say first name, then you say varchar, and you give it a number afterwards. That number is the number of characters that you want that column to hold. For example, if you said like first name varchar 3, that means you could only hold a 3-character string, like ABC. But if you tried to store something like A, B, C, D, E, F, G, it would just cut off the D, E, E, F, G. But if you specified something like varchar 1000, you could hold something with up to 1,000 characters. And by character, I mean any letter, capital or lowercase, number or symbol like commas and exclamation points, etc. The max that you can do in a varchar is 65,535. So if you just don't want to worry about a limit, you can just put that highest number. Then we have ints or integers, and these hold whole numbers, which can be either positive or negative. You have a decently big range. If you needed something higher or didn't need something this big, there's other options, but you don't have to worry about that in this class. This is plenty good for what we do. Most like primary keys would use an int. Then we have decimal, or you can shorten it to dec or dec, whatever you want to call it. These hold decimal numbers like prices. So you can specify decimal data types as decimal, and then you give it 2 numbers, one followed by another with a comma between them. So first you specify the total number of digits, including the decimal places, and then you specify the number of digits after the decimal point. So for example, if you specified 6, 2, that means 6 total numbers, but 2 of those 6 numbers take place after the decimal point. So that means you could hold 4 before the decimal point, like 9,999, and then you can have 2 after the decimal point. So you can do it positive or negative. So a 6, 2 could hold any number between these two amounts. Whereas if you still did 6 but you did 4, that means you're only holding 2 numbers before the decimal point, but then you have more precision afterwards, up to 4 places afterwards. And then afterwards we have date time. So that holds dates and times in one column. If you want to, you can go back up to this link that I specify here. And later on in SQL, they added other data types to just hold date and time. And sometimes that's more useful, but date time was made earlier, so it's more common. You'll see it in more places. So you don't have to specify anything in parentheses afterwards. You just put date time. So an example of me creating one of these is, let's say we wanted to create a table called student, and this is on purpose. I'm making it very simple, but we just type out create table student, we have a parentheses, and then we list the names of the columns we want, followed by the data types. With int or integer, you don't need to put anything afterwards. With varchar, you have to specify the character limit. I'm just going to put 1,000 just to be safe. You shouldn't run into any first names or last names that are over that. And then an admitted date, and I'm just going to put a date time there. So between each one of these, you need a comma, except for the last one. Just make sure it ends in a parentheses, and then of course a semicolon. Let me run this. I might have already created this table, so if it gives me an error, that's why. Okay. I'm going to pop back up here. I'll explain what I'm doing. But if you run this, you should be able to see down below here that it gives you a green check mark. You're able to run this correctly. So now you can actually select from this table, and it works. You can see that you have these 4 columns that you listed out here, but of course we don't have any data in there yet. And then if I try to run this create statement again, because I've already created the table, it already exists in the database. Then it's going to give me a red X, and it gives me an error here. Table student already exists. So that once you've created it, you can't create a table with the same name again. You'd have to change the name. But if you want to get rid of the table, the way to do that is to just do drop table. So you can run that here. And you'll notice that if I try to select from student again, it's giving me an error again. It's saying that student does not exist. That's because we just deleted it. And as a warning, there's no undo button with databases. I'll show you something that sort of functions like an undo, but it's not at all like something like you might have in like Microsoft Word, where you type something wrong, you just push Control Z or Command Z to undo it. So just be very careful if you ever do drop a table. But now that we've dropped it, let's just create it again and start messing with it. So we'll create that. That went through. We see we have the student table again. Nothing's in there. So let's put some data into our table. So first we do this using an insert command. Just like before we did create and then the table, here we're doing insert, and then you have to follow it with into. Then you specify the table name. In this case, we're using student because we just made that. Then you can specify the column names, and these can be in any order that you want, which I'll show. Then after that, you specify values, you put parentheses, and then you put the actual data into those, and they correspond with the order that you specified up here. For example, I did student ID first. That means the first thing that I put into the values parentheses list has to be the student ID. The second name, or the second thing I put is first name, so I'm putting Jacob here, so on and so forth. Then with dates, if you forget, remember to just use a format like this, which is the year-month-day. So when I run this, it shows that I did it correctly, and I can select from student, and you can see that now our table has the data into it. So to show a few variations on these insert statements, you can change the order of the columns. Just make sure you change the order of the data that you're inserting. For example, I'm doing first name first, then student ID. This is exactly identical to this above statement. So if I run this here and then come back, you can see it entered in another identical row there. So it worked. You can also leave out columns. For example, I'm only specifying the ID, first name, and last name. I'm not putting a date. So if I were to run this, that also works, and you'll see we just have a null value here. It leaves it empty. So if you want a shortcut, especially if you know what order these columns are listed in, you can actually skip writing out the column names. In this case, I'm just doing insert into student and then skipping ahead to values. Just make sure that the order you put the data in matches the order of the columns as they appear when you originally created the table. If you forget what that order is, it's just the order that appears when you do like a select star from that table. So I could run that. That's also adding another one of those rows to it. And you can do the same thing, but let's say you wanted to skip first name. You could just specify null there. So let's do that. And since first name is the second spot, you'll notice in this most recent one, that column is now left empty, or it says null. If you want to, you can also insert in multiple rows at once. And when you do this, if you choose to include the column names, you only have to show the column names once. You only type in values once, and then you just give another set of data columns to insert. Just make sure you include the column right here between each one, except for the last row where you don't include a comma and just include the semicolon. So if we were to run this and then see what we insert into it, you can see that we inserted 3 rows just in one go. So that's the basics of creating and then inserting tables, data into your tables. But you'll notice something that might be weird, especially from looking at our tables in REDCat, where student ID, which should be our primary key, we know that primary keys have to be unique. But if you see here, I was able to insert multiple rows that all had an ID of 1. So that's a problem. That's not good database design. So let's try and fix it. So what I'm going to do is I'm just going to delete the student table to start over. And then when I recreate it, I'm just copying what I had from above. But at the very end, after you specify all of the column names and their data types, just make sure you add a column, and then you can specify which of the columns you already listed should be the primary key. In this case, we want student ID to be it, so we just list out primary key, and in parentheses, put student ID, and let's run that. So just like before, we can insert in data. We have Jacob Steffen with a primary key of 1. Let me just do a select statement so you can see it's going in there. Student. So you can see it went in there, but let's try to insert that in again like we did before. And you'll notice down here we get the red X and it says error code 1062, duplicate entry for 1 for key student.primary. So it knows that this is a primary key and can't accept something that already exists. So it's just going to reject that entirely. It did not enter in another row there. The same thing would happen if I were to try to leave the primary key empty. If I just said null instead of an actual integer value. If I did that, column student ID cannot be null, so it doesn't let me do it. But as soon as I provide it with a new value for the primary key, in this case 2, it's going to work. So that went through with the green check. Let's look at our results, and you can see we have 1 and 2 there. So primary keys, by specifying that, which is called a constraint, we're constraining what kind of data we can enter into our database, because we want to make sure the structure is sound, that there's not bad data within it. Another constraint that we can add is something called not null. And this is where if we wanted to make sure that the other columns were always filled out, we never wanted to add a row that didn't have these columns in there. And you do this just by specifying not null. So I'm going to drop the table so that I can recreate it with this new specified constraint. So I'm running it here, and the way you do this is just right after the data type. In this case, let's say we wanted first name and last name to never be empty. We always wanted to make sure there was data there. Just right after the name of the column and the data type, you just add a space and then specify not null and then do a comma like you did before. And we already ran that. So just like before, we can insert data into it and we can see it. It works just like before. But let's say we tried to put a null value or leave it empty for first name or last name. In this case, first name, we're trying to insert in something null. Then it gives us that error, error code 1048, column first name cannot be null. So that's just another way to add constraints to your database to make sure that the data that you're actually storing is going to be stored in there the way that you want it to be stored. And you'll notice that we didn't specify not null on student ID. You could, it wouldn't hurt anything, but by specifying student ID as a primary key, and since primary keys can never be null, you always need to have them, by default it also will basically add that not null constraint to anything that's a primary key. Okay, so that's creating a table, dropping tables, inserting data, adding constraints to that data. Now let's do some simple updates and deletions, and there's different ways you can do that, but let's just do some pretty simple examples of this. So just to get rid of the data that we have so far, I'm going to drop it and then recreate it, and this is exactly what we did before with the not nulls and the primary key. And then I'm going to just add in multiple rows at once so we have some data to work with. So let's see what we got so far. Okay, so we have a student table, and we have 6 different students here. So when we did the insert into command, we added a new row every single time that we would run that, like in this case. Every single one of these lines becomes a new row. But if you want to change something in a row that already exists, then you have to use the update command. So you just do update, you specify the table name, in this case student, you use set. So update student set, and then you do any columns that you want to update, followed by commas. This case, let's say that they entered my name wrong. It should actually be spelled this way, which it isn't, but just for this example. We could say that we want the last name to instead be Stefan with a PH and first name be Jacob with a K. And then just like when we're doing select statements, we can specify a where statement. This is because we don't want to update every row. We only want to update my name here. Since I have an ID of 1, using IDs is by far the most common way that you're going to update something. So if I run this and then select from student, you can see that it changed first name and last name, but only for me because I have that student ID of 1. And you can change this to other things, like let's say you wanted to update the name of students that were all admitted on the same date or something. You could specify that in a where statement, just like you do in a select statement. But most commonly, you're probably going to be working with primary keys because you want to be pretty specific about what you're changing in most cases. Also, as a warning, you can run this query and notice that I'm updating it. I'm saying last name to Stefan, first name Jacob, but I don't have a where clause. This query is valid. You're able to run it, but what this would do is it would change the first name and last name of every single row in the table because we didn't specify which rows to limit that change to. Right now, I have your databases set on a safe mode. So if you tried to do this, it's going to give you a red X and it says you were using safe update mode and you tried to update a table without a where clause that uses a key column. So you can disable that, and I might do that later for some of your assignments. But be careful because not all databases might have that safe mode implemented. Then we get to deleting, which is very similar to update. Really the only difference is that instead of insert into, update table set, you're just specifying delete from. You specify the table, and since you're deleting entire rows with delete, you don't specify any column names. You just specify the table, and then like before, you specify which rows in that table you want to delete using a where clause. In this case, I want to delete my row, which has the ID of 1. So if I run that and then go back to student, you'll notice that student ID, that whole row is now just totally gone. So similar to the update, you can also do delete from, and it's going to stop you because safe mode is on. But if you didn't specify a where statement down here, and if it weren't in safe mode, this would just delete all rows in the table. That's different than dropping a table, where dropping deletes the entire table as well as all the rows because the rows are part of the table. Whereas if you just deleted all the rows in a table, it would still keep that table. It would still have the structure with what you set as the columns and any primary keys and constraints. The table would just be empty without any rows. So I think that's good for now. So we learned how to create tables. We learned about some simple data types. We learned how to insert data into those tables, how to specify constraints, and then how to update data that is already there to change values that are already existing, and how to delete rows. So that's the basics of creating, updating, and deleting. I'll show you a few other ways that you can create and update things. But for now, I think that's a good place to start. So please just let me know if you have any questions, and I'll be happy to update you on anything. Thanks.